Welcome back. Today we're going to be looking at maths and logic in Python, and hopefully by the end maths will have been made a lot easier for you. So if we take a computer chip, then this computer chip is made up of so many different logic gates, and if you aren't able to compare stuff, then you have to just go through the same process again and again and again. It's not going to be very useful. So logic gates allow us to do calculations and give our program branches. So very simply, you've got various symbols to compare two items. Most of them are fairly straightforward, so greater than is the same as it would be in maths, less than is the same as it would be in maths, greater than or equal to, because there's not really a symbol that represents that. You do greater than and then equal to, which makes it quite easy to remember. And the same with less than or equal to. So let's have a look at what this means for comparisons. So if we start with the simple one, we're just going to say 3 is equal to 3. And of course, this is true. And then if we say 3 is equal to 4, obviously that's false. And then you can do the same with text. You can say A is equal to A, and it's true. But something interesting to note is if you say 3 is equal to 3, you get false. You can also compare numbers, so 4 is greater than 2, 4 is less than 2, and you see the same thing. And then with greater than or equal to, 3 is greater than or equal to 3 is true, but then 3 is greater than or equal to 4 is false. You can also compare letters, and it sorts them alphabetically. So we compare A with B, we see that that's false. But if we say A is less than B, we see that that's true. It's also quite similar with capital letters. So A is less than B again. But when you get lowercase and uppercase, it's slightly different. So we've got Z at the very end, and that's going to be greater than A. So it supports uppercase letters as having a lower value than lowercase letters. And if we then compare numbers and letters, we see that it's not going to let us do this. And because you can't compare numbers with letters, which should make sense. But if we have numbers as text, we can see that that's false because it's compared them alphabetically. So hopefully that gives you some idea of doing logic. So if we then move on, you can combine statements using and or not. So if 3 is equal to 3 and 4 is equal to 4, it's true. And if 3 is equal to 3 and 4 is equal to 5, you can see that's false. And as this table highlights, the logic statements are very simple in Python. In other languages, you use various characters to represent different logic statements, but in Python it's very simple. And we do the same thing with an OR. This is going to be true. And this is also going to be true, because for OR, only one of them needs to be true. And then not, you can see that not 3 is equal to 3 is going to be false. But not you can only do with 1. So if I try a not in the middle, it's going to give me an error. Because you can't, because we need an and obviously you can combine more and more of these. And we get our desired result. And in logic, you can also use brackets, and it takes account of the thing in the brackets first. So 3, 4, and 5, 5, and you can see that part is going to be false, or 3 is equal to 3, and not 4 is equal to 2. And the second half is going to be true, so the whole thing is true. Then we've also got maths, and you can see the first 4 symbols are fairly straightforward, but going down is a little more complicated. So we'll just do 3 plus 5, 8, 5 times 25, 125, 79 divided by 3. You can see that at the end kind of goes funny, and that's because it can't possibly store fractions, so it has to store it as a decimal, and you can see that it's ever so slightly imprecise. But if we then take this number and multiply it by 3, it then resurrects that mistake because it calculates it and gets that it's not perfect and then naturally rounds it. And then subtraction as well. You can get negative numbers. You can have 5 minus 8, you get negative 3. And you can subtract negative numbers. So this is saying subtract negative 8. The next one we're going to look at is flawed division, which is where if you take 2 numbers, it gets rid of the remainder. So if we go back to our 79 divided by 3, see that it's 26 and a third. But if we floor divide, it gets rid of that third. And then if you've got integer division, it will just round it anyway, so that's equal to 5. Mod is going to look at the remainder. So we take our 79 example again, use percentage sign, and it's just going to look at the remainder, which in this case is going to be 1, so it'll be 1/3. And if you divide something that's perfectly divisible by something else, say 5 mod 5, it would be 0. It's kind of interesting with negative numbers though, because if we do negative 5 mod 1, we get 0, and if we get 0, and if we do negative 5 mod 2, we also get 1, so it will make it positive. If you do mod with negative numbers, also gets kind of strange, but generally you'll stick with positive numbers. And the final one is powers. So say 3 to the 4, 3 to the then we're going to get 81, because that's the same as just doing 3 times 3 times 3 times 3, 4 times. And you can do non-integer powers, so if we do 5 to the half, you notice we get 2.5, because actually what it's done there is 5 to the 1 divided by 2. So like in logic, you can use brackets in maths. There we go, and that is the square root of 5. We also do decimals, so we get root 2 there. And then you can combine maths and logic, so you can get 5 plus 5 is equal to 10, tell us it's true. And 5 plus 5 is less than 6. You notice it's false. And you can sort of see and play around with this a bit yourself if you want to understand it a bit better. So, thanks for watching. I hope you're fully confident with maths now. See you again next week, same time.